Hi, my name is Jake, and just going to be going through how to install and then exploit three purposely vulnerable SVCs. And so, if you need to have sysgen downloaded, so download that, and then we're going to be the first thing to do is once it's downloaded. You need to go into the conf and change it so that on IPL the LPA is refreshed, because if you don't do this, even if you change the binary that the SVC is going to be using, it won't change the stored code that you're actually executing unless you put this. So start NVS, and then you need to send the install JCL to the reader. And this install JCL also has example code which will exploit the SVCs, but for this purposes we're just going to run it without knowing what's in the JCL. So we've installed 3 SVCs, and then you need to exit and re-IPL, and then those SVCs will be put into the LPA. And the reason why we can do this is that the MVS sysgen system comes with a load of dummy SVCs. So these are ones which get loaded, but they're just a branch back. They're just a BR14, so it doesn't actually. The SVCs don't do anything, and it's packed decimal. So 24A is 241, 24B is 242, and 24C is 243. And what an SVC is it's just some code that can be run with a special assembly instruction, which is OA and then the number. So, for example, SVC35 is the WTO instruction or WTO macro, and so when you run SVC35, that will execute the code which is stored there, and on entry to that SVC you will be in supervisor state. So if there's a vulnerability in that SVC, you'll be able to get local privilege escalation. So the username and password we're using are MVSCE2, and the password is pass for you. And we're using this one because it's a low privileged account. So if we, for example, go to sys1.secure.cntl on the MVSCE system, this is where the usernames and stuff are stored, so only for example, the IBM user has access to this, because we tried to open it and it says access denied. So for these SVCs, what we're going to do is we're going to use the 3 SVCs that we've installed in order to access this sys1.secure.cntl dataset. So we want to this is already installed on this one, but if you install show MVS, this will list the SVCs. So you just need to alloc sysprint and run show MVS. So this gives us the SVC table. And we want 241, 242, and 243. And this C0000 means that anyone is allowed to run this SVC. Okay, so let's just run one of these SVCs. So if we go to okay. And then we okay, so we oh, I forgot to so now when we submit it, the SVC gives us a helpful error message that says get out of here, and we end the SVC. So let's try doing a so this is the macro that we're going to do, but when I like to write shellcode, I like to write it in just assembly, because you want to have control over where things are being, how things are being written. So let's just do this, and mode set is SVC 107. So now when we run this, we get a S047 authorization error, which means that after this SVC, we have the same authority that we had beforehand, and we're not allowed to, in our own code, say I want to run stuff in supervisor state. So let's have a look at what code is actually being run, and we can do this by doing a test on IEFBR14. Doesn't really matter what we pick here, we're not actually going to run it, but we do a list. Okay, so we can see that we are, so typically you'll see this on the on entry on an SVC. We want to know where we're entering so that we can then use that as a base register. So it's doing a booler 12.0. It's then writing to memory from that address. So this, we don't have control over this because this is its memory. It's then doing a CLC and looking at, so 92 bytes after this address is going to be checking 7 bytes against what was in register 1. Register 1 is a register that we control. on entry to SVCs, you're allowed to you have control over register 1, 13, and a couple others. I can't remember exactly what's, but there's some registers which, like for example, register 6 will always point to a TCB or something like that. It's not important for this, but register 1 is something that we control. So let's find out what was 92 bytes after this. So we list. Oh yeah, and so 5C. XM7. Oh yeah, because all it does on it's from this address. It sets the R12 to the address of the next instruction, so it's F2 that it's going to. So it's F2 plus 5C. Okay, so we list. So what it's saying is it will compare the secrets to the what's stored at the character string at R1. So, and then it will branch. I think 7 is branch if not equal. So so branch on condition is, so if we didn't pass its secrets, it will add 58 to this. 58, it'll add 58 to that, and it won't run this code here. So let's pass this. So let's add 58. And so this is a typical thing that IBM SVC macros will do, is it will do a branch and link around what we wanted in the in register 1. So you can see that this will branch, and it will branch to here, and the value of this will be in register 1. And this is a this is the parameter list of a WTO, and it says that it wants the length of the WTO to be 13, and then send this message, and that is C7, C5, E4, E3, 40. And so that was the thing which generated that get out of here WTO message. So let's go for the other path, which is we will pass secrets in R1. So let's go back to this. Okay, so add a key, CL7 secrets, if I can spell. Okay, and we want to load the address of register 1 with the key. Okay, and we run it again, and we can see that oh yeah, 16B is a oh yeah, 16, yeah, okay, I forgot to comment out this line. 16B is we were bending in this routine, but let's run it again. Okay, you can see that we now did we got a return code 0, and after God mode was activated. And what God mode was so let's go to the so we did this. So this is the WTO that sends out God mode activated, and after that it branched 84 bytes after this. So 54. Oh, sorry, no, it happened here. This is so after After it does the God mode activated, it loads the return registers, clears out register 15, and branches back to R14. And R14 is set on entry by the SVC, and that's what returns control back to our program. But what we need to look at is these 3 instructions, and so unlike a kernel program in Linux, we're running in the same address space when we do an SVC, unlike a syscall. So in Linux, when you do a syscall, you go to some special kernel space, and all the magic stuff happens there. In ZOS and MVS, you're in the same address space. So if it changes some bytes for the privileges that you have set, that's changing it for your address space. So in this case, the job that we're running here. So what this is doing is it's loading a control block, which but I'll just tell you what this control block is, because you start to know it. You start to recognize the numbers once you see them every so often. But this is loading the JFC. This is changing the JFCB auth bit, and what that bit says is, are you allowed to run mode set? And if this is just flipping it on. So if this part of the code is run, then when we branch back to our actual code, we'll be able to run mode set. So now we've run mode set and we're in key 0, we can make it do anything we want. And what we're going to do is go to the ACEE, and this is something which is in RACF, and it's a thing that says, don't check whether I actually have access to something, just let me have it. So you can set something called operator, which lets you have access to any data set. And we want to flip the bits on, and this will flip on special bit, which is something, and operations bit. So now when we run this, we still have it, but now we need to actually do something with it. And it's specifically not our user here, which has access to, so we still can access that, but in the job, if we say read the data from here, in this step we're going to have operations. So if we run it again, then we go cat, and we're IB generating it, and we're sending it to sysout equals A. So if we go to printer, and we now see all the usernames and passwords on the system, and so now we've exploited that SVC. Okay, well, I think I'm gonna leave it at that, and do a video for the other 2 SVCs at some point. But yep, that's me done.